Okay, so the next problem we are solving in lead code is majority element. Okay, so here we'll be given the list of numbers. We'll have to find a number which is occurring more than half of the length of the list. Okay, so let's say the length of the list is 3, right? So a length will be 3, and what will be the half of its value? It will be like 1.5, and if we just round it off, we can say 1. Okay, and if it is like, we'll have to find an element which is occurring more than one times. Okay, that is 3 here, and it is being said that there is for sure there is a majority element in the given list. Okay, so this is a given list of numbers again. So what is the length here? 4 plus 3, 7, right? 3.5 it would be. So the middle element will be 3.5, and we can, if we round it off, it will be 3, right? We'll have to find a number which is more than 4 which has occurred more than 3 times. Okay, so that is the problem about, and the approach used here is, so first we'll find out what is that number, right? Like, I mean, required number. Let's say that we have the length 8. Okay, and we'll have to find a number which is occurring more than 4 times, right? So we'll find out that required length, and here what we are currently doing is, we are trying to do the store the occurrences actually. Okay, we'll iterate through it, and we'll store the occurrences, and to make our task easier, we'll use the default dict. Okay, so what does this do? Like, I mean, it will help us in not storing, like, I mean, it helps us in avoiding writing some additional code saying that if this value exists or not. If it exists, only then append. If it does not exist, add one. Like, all those calculations can be reduced using the default dict method. Okay, default dicta method. Okay, so now what we'll do is, we'll set this thing, and whenever we iterate through it, we'll increment the occurrences. Okay, and whenever once we increment it, we'll check if the occurrences has crossed the required length of the length of the list, right? If it is crossed at one point in time, one element, at least one element will cross that, and we know that there will be, for sure there will be one element that will be occurring more than half of the length. So we'll be returning at that point of time. This is one approach. Like, I mean, this is like kind of open complexity, and it also has a space complexity actually. Okay, and so now we'll check the like, I mean, so now we will check the Boyer-Moore voting algorithm. Okay, so this algorithm also gives the same result, and also have the same time complexity, but space complexity wise, it is the better one. Okay, so what we are trying to do here is, it is mostly the same. Like, I mean, it has like, I mean, kind of easiest approach. Like, I mean, what we are trying to do here is, we are trying to check, like, I mean, in a given number, right? We'll consider each number as a member. We will be iterating through it. Okay, we will be iterating through it each, and we'll set the counts. Okay, let's say that when we start this thing, we'll set whoever comes, right? We'll consider them as a majority candidate. Okay, and then as we keep on counting the occurrences, we'll be incrementing the counts for this guy. Okay, if we found someone else, like, I mean, we'll be decrementing the counts. Okay, at some point in time, let's say that if this was not a majority guy. Okay, so this ended somewhere here. Okay, 2 2, and the count will be 2, and count will be again reduced to 1, and ultimately it will go to 0, right? So what does it signify is, let's say that at some point in time, if the count is becoming 0, it means that someone else is taking a lead. Correct? Like, I mean, it is like, I mean, if you are trying to count a member, and it is like, I mean, the occurrences is not exactly the off of it. Correct? So in that case, what we'll do is, we'll change our candidate to whatever that is there, and we'll try to do the same. Okay, at some point in time, like, I mean, so the main reason how it works is, like, I mean, by definition it says that, right, appears more than half the time in the list. Correct? And when the count drops to 0, it means that the number of times the current candidate has been matched is equal to the number of times other elements have been encountered. Correct? So thus, like, I mean, if there is a majority element, right, it will be the last candidate standing. Okay, yeah, these are the two approach for this to find out the majority element. Yeah, that's it. Thank you.